All right, 4.3, writing equations of parallel and perpendicular lines. A couple things. First, some vocab. Parallel lines. Remember, parallel lines exist in the same plane. They're lines that will never intersect. They're marked usually with a little arrow in the middle, like so. If you were to see lines going like so and have two markings, that means they would also be parallel. Line with two markings means parallel, another one with two markings. Usually we would write, for instance, if we called this line L and this one line G, we would say line G is parallel to line L. Okay. Something to also note, parallel or slopes of parallel lines are equal. Okay, they're equal. They're the same. Okay, or yeah, you could say the same. Okay. Perpendicular lines intersect at a right angle. You have your little right angle marking there. If we said this is line L and this is line M, we'd say line L is perpendicular to line M. Use that upside down T. Slopes of perpendicular lines. You'd note if I had a perpendicular lines like so here, the slope of this line, line L, and this line, line M, the slope of line L is a positive slope, where the slope of line M is a negative slope. Okay, so this would be a negative, this would be positive, and that's going to always be the case. So always be the case. So slopes of perpendicular lines are inverses of each other. In other words, they're opposite sign or negatives. Okay, there's another way of thinking about it. They're negative. Okay, so if one's positive, you change the other one to negative or vice versa. Okay, and they're reciprocals. So if you're not sure, can't remember what a reciprocal is, remember a reciprocal would be, say, if I had a slope of 1/2, the reciprocal of 1/2 is 2 over 1. Okay, or 3/4, it would be 4 over 3. So if I wanted perpendicular, if I was looking for perpendicular, say if this was positive 1/2, this would have to be negative 2. If this was positive 3/4, or even let's go with negative 3/4, this would be positive 4/3. Okay, they're inverse reciprocals of each other. All right, so knowing that, what we can do is then we can determine if lines are parallel or perpendicular using slopes. So if I were to look at, say, line A here, line A passes through 2, 5, and 3, 2. So are they parallel or perpendicular? And what we'd have to do is we'd actually have to use the slope formula. Remember the slope formula, M, which stands for slope, is equal to y2 minus y1 over x2 minus x1. Okay? And so I'm just going to find the slope for each of these. So line A, my slope is, well, I'm going to have 4 different spots. Okay? My y2, y1, x2, x1. I'm going to go ahead and label everything in this spot will be x1, everything in this spot will be y1, everything in this spot will be x2, and everything in this spot will be y2. You could label them any way you want, but I'm just going to go with that since this is my first x coordinate and first y coordinate on each of these, and this is my second x and second y on each of these. Okay, so I'm going to go 2 over 3 and 5 over 2. Okay, that's y2 minus y1 over x2 minus x1. Okay, so the slope of this is negative 3 over 1, also known as negative 3. Okay, line B, going to do the same thing. Okay, so we have negative 2. Negative 4. Notice the parentheses are a big deal there. Oops, that is not right. Negative 2 is right. The negative 4 is actually, that's my x. Okay? And then negative 1, negative 1. Now when I fill these in, I always put y over x, so y over x and y over x, but it fills it in a lot easier for me anyway. Okay, so I get -2 minus -1, and those double negatives make positive, so -2 plus 1 is -1. And then -4 minus -1 is the same as -4 plus 1, which is -3. Okay, so we have that is equal to 1/3. All right, and then letter C, 4 spots again. Okay, -1, -4, and 1, 2. All right, so -1 minus 1 is -2. And -4 minus 2 is -6, which gives me 1/3. Negative divided by negative is 1/3. Okay, so since these slopes are the same, these two lines are parallel. B is parallel to C. And we would want to say Y, slopes are both 1/3. Okay, so use math to tell Y. You could also say that since this is -3 and this is 1/3, these are inverse reciprocals. So B and A are perpendicular, as well as A and C. A and C are also perpendicular here. Okay, so let's go ahead and label that a different way, kind of rather than kind of the messy way there. We could say A perpendicular to C, and A is perpendicular to B because slopes are inverse or negative reciprocals. All right. Very good there. Okay, so two different answers here. Okay. Let's try another one here. Determine which lines, if any, are parallel or perpendicular. So now we're looking at equations here. All right. Well, the first one they actually put in slope-intercept form for us. That's kind of nice. So it's easy to identify with line A. To find my slope, to see if they're parallel or perpendicular, we just have to identify the slope. So I'm going to try to get them all in y equals mx plus b format, and then identify the slope. That's what I'm looking for. So line A, it's already in y equals mx plus b, so the slope is -5/3 is m. Okay. Line B, I actually have to do some math behind it. Oops. Okay, so I'd have, I'm going to go ahead and write it here. B, we have -3x plus 5y equals 10. And I'm going to try to get y by itself, so I'm just going to start manipulating my equation. I'm going to move these x's over. So I have 3x to both sides. Okay, that gets rid of it there. I'm left with 5y is equal to 3x plus 10. Divide by 5. Divide each term by 5, that is. Y is equal to 3/5 x plus 2. Okay, there's my slope. Okay, so slope for A, right here. Slope for B, right here. Okay, so m is equal to 3/5. Okay, and then C, 9y equals -45x plus 36. Okay, to get y by itself, I'd have to divide each side by 9. All right, 1y is equal to, that's a 9 there, -5x plus 4. Now me trying to make that a 9 made it look like a weird thing there. And it's not a 4, it's a 9. Okay, and that gives me 4. Slope, -5. All right, so looking at these, well, I have a slope of -5/3 and -3/5. Okay, well, that's good. Looks like these two are perpendicular. A is perpendicular to B because slopes are inverse, or also known as negative reciprocals. Okay, we flipped it and we changed it from negative to positive there. All right. Check some other stuff out here. Write an equation of a line that passes through the given point and is parallel to the given line. Okay, this is where it gets a little tougher, so let's go ahead and try this. So first, in order to write an equation, we have two different forms we can use. We've learned about y equals mx plus b, okay, which is called slope intercept form. And then we've also learned y minus y1 times x minus x1, which is called point slope form. Please note that these both have in common the word slope. Okay? So in order to write an equation of a line, you need to first know the slope, no matter what. And in slope intercept form, you need the slope and y-intercept. Okay? So when we say intercept, we're talking about y-intercept. To use point slope form, we just need an xy coordinate and a slope. Okay, so I'm going to look at this and I can easily identify the slope. Slope is 4/3. Okay, it's in y equals mx plus b format. They want it to go through this point and it's an equation of this line. So two different things here. We're going through this point, and this is the equation of the line that has to be parallel to. Okay, so we know since it has to be parallel, we know that our slope has to be the same. So it's going to be 4/3. They're going to be equal slopes. We also know a point, an xy coordinate. Now when I look at this, I'm going, okay, I've got the slope. Now do I have the y-intercept? Well, in order for it to be the y-intercept, x would have to be 0. So no, I don't have the y-intercept. Do I have another point? Yeah, I have this point. So I'm going to use point slope form. Okay, I have a point, negative 3, 2, and I have a slope. Okay, so I'm going to use point slope form. So y minus y1 equals m times x minus x1. Okay, so I kind of distinguish or determine which I use based on what I'm given. Okay, which form I use. So I go y minus 2 is equal to m, 4/3. Notice I put everything in parentheses. X minus x1. Anytime you substitute, put parentheses. It'll save you headaches later on. It gets a little messy looking because sometimes, like here, the parentheses don't mean anything, so I just rewrite it afterwards. The 4/3, it didn't do anything. However, right here, notice that's a double negative, which means plus. Okay, now if it doesn't say write an equation in point slope form, then you should really change it to slope intercept form. So this is point slope form right here. Okay, I'm going to go to slope intercept form by distributing that 4/3. So we have y minus 2 is equal to 4/3 x. And then 4/3 times 3 is plus 4. And then I'm going to add 2 over to both sides. And I get y is equal to 4/3 x plus 6. So an equation of a line that is parallel to 4/3 x plus 1 and goes through the coordinate negative 3, 2 is this right here. And you can check that. You know it's parallel. You can just plug in the point and see if it works. Okay, 4/3 times negative 3 is negative 4 plus 6 is 2. Hey, it works out. Here's my equation. All right. So the last thing here, we're going to go ahead and write an equation of a line that passes through a given point, and this time is perpendicular. Okay, and so once again, here's my equation, and here is the point. And we've already determined if you're given a point and you know the slope, you're going to use point slope form. So I'm going to first figure out the slope. It's in slope intercept form right now, this line. There's my slope. If I want a line that's perpendicular, a perpendicular slope, we have to take the reciprocal. So 5/2 becomes 2/5, and then it goes from positive to negative. Okay, so I'm going to use y minus y1 equals m times x minus x1. So I hope you pause these and try these on your own, but I get y minus y1 is 3 equals m, negative 2/5, times x minus x1, which is negative 2. Once again, those parentheses there, you may just rewrite it without them once you're done, but sometimes it makes a difference, like right here, that double negative becomes plus. Okay, there's point slope. If it doesn't say to use point slope, then write it in slope intercept. So we distribute, we get y minus 3 is equal to negative 2/5 x, and in this case, we get plus let's see, negative 2/5 x plus, or excuse me, not plus. Oh, don't want that. Let's try this again. Okay, minus 4/5. Okay, and then we're going to go ahead and add our 3 to both sides. Okay, that's gone. I'm left with y is equal to negative 2/5 x plus. If you have a hard time with fractions, just think, hey, 3 whole is how many fifths? And so you can think of 3 whole as 15/5, because 3 or 15 divided by 5 is 3. The way I change that so fast is I say, hey, I want 3 to be in fifths, so just 3 times 5 is 15. So it's 15/5. Okay, so negative 4/5 plus 15/5 is positive 11/5. There's my equation. Kind of ugly with the fraction there. All right, that's all I got for you. Good lucky.